This is 1.5, solving absolute value inequalities. In the last section, we graphed absolute value inequality. So we graphed our V shape for our absolute value and shaded either above or below the inequality. Now what we're going to do is we're only going to solve for the X values. So instead of finding all of the points, we're going to just find the X values. So for the first example, what we're actually going to do with these problems is we're going to treat them exactly like equalities. So what we're going to do is we're going to say, let's set 4x plus 5 greater than 13, and then negative parenthesis 4x plus 5 greater than 13. Okay, so I'm doing exactly what we did for equations. So it's setting up two equations, one positive and one negative. And I'm going to solve these just the same. So I'm going to subtract 5 from the inequality on the left and get 4x greater than, let's see, 13 minus 5 is 8. Divide by 4 and get x greater than 8. Same thing for the other inequality. So I'm going to go ahead and distribute just like we did before. And I'm going to get negative 4x minus 5 greater than 13. Add the 5. And get negative 4x greater than 18. Divide by negative 4. And then I have to remember something from Algebra 1. When I divide inequalities by a negative number, so I have a negative number here, I have to remember to take this inequality that I have and reverse it. Okay, so I'm going to flip it. So we're going to say when dividing by a negative, flip inequality. And I'm going to go even farther, and I'm going to say when you're dividing or when you're multiplying, just in case you have a fraction and you have to multiply by a negative. So I'm going to go ahead and make that greater than or less than. And I've got negative 18 over 4. I could leave it that way, but 18 over 4 does reduce. So I'm going to go ahead and make this x is less than, let's see, both of those divide by 2. So 18 divided by 2 is 9, and 4 divided by 2 is 2. Now what I'm going to do is put both of these on a number line. So we're going to graph these because a number line is just like the x-axis. So this is going to give us a visual of what x greater than 8 and x less than 9, negative 9/2 looks like. So I'm going to put the lower number on the left, which has to be the negative number because negative numbers are lower than positive numbers. And then I'm going to look at those inequalities. So just like we did when we were graphing, a less than is going to graph differently than a less than or equal to, and a greater than is going to graph differently than a greater than or equal to. If you have less than or greater than, you're going to have an open circle. And if you have a less than or equal to and a greater than or equal to, you're going to have a closed circle on your numbers. So because both of these are a less than and a greater than, I'm going to have open circles. And then the inequality is actually kind of acting like an arrow, and it's going to tell you which way to point. So because this is x is greater than 8 is like 9, 10, 11, 12, that's going to mean shading to the right. And for the less than negative 9/2, well, less than negative 9/2 is like negative 100, and that's going to the left. Okay? So some people like to think less than means shade left. Some people like to look at these inequalities and think of them as like arrows pointing in the direction that you're supposed to shade. So the greater than pointed to the right, so we shaded to the right. Whatever helps you. Okay. And I can check these in Desmos. So it's easy enough for me to hop over to Desmos and type this in. So let me go over to Desmos and type in absolute value of 4x plus 5 greater than 13. Okay, so we'll say 4x plus 5 greater than 13. So what happens on here is we can check our shading. We've got a weird fraction, which is kind of a bummer, but that's okay. We can at least estimate what's going on. And so I see I have dashed lines. The dashed lines on here represent your open circles, and the shading is away from the dashed line. So it's outside the dashed lines. So that's always a good check. All right, let's look at the next example, which has a little bit different shading. So for this next example, I'm going to, again, set up my two inequalities. So I'm going to say x plus 4 greater than or equal to 6 and negative x plus 4 greater than or equal to 6. And for the inequality on the left, I'll subtract 4 and get x greater than or equal to 2. For the inequality on the right, I'm going to distribute my negative. So negative x minus 4 greater than or equal to 6. I'm going to add 4 and get negative x greater than or equal to 10. Divide by a negative 1, and remember, when you divide by that negative, what happens to that inequality? You have to remember to flip it. So I'm going to say x less than or equal to negative 10. So between 2 and negative 10, I have to decide which one is less. The negative 1 is going to be less, and the positive is going to be greater. This time I have or equal to's. And so just like we mentioned up here, when it's a less than or equal to or greater than or equal to, you want closed circles. So I'll do a closed circle and a closed circle. And then I'll let the inequalities tell me which way to shade. So x greater than 2, so greater means shading to the right, and x less than negative 10 means shade to the left. Next example. So again, I'm going to set up my two inequalities. So I'm going to say 2x minus 7 greater than 1 and negative parenthesis 2x minus 7 greater than 1. And I'm going to solve. So for the one on the left, I'm going to do plus 7 and get 2x greater than 8. Divide by 2 and get x greater than 4. For the inequality on the right, I'm going to go ahead and distribute. So we'll say negative 2x plus 7 is greater than 1. We'll subtract the 7 and get negative 2x is greater than negative 6. We'll divide by a negative 2, and remember, we're dividing by a negative, so don't forget, we're going to go ahead and flip that inequality. So we're going to say x is less than 3. All right, so we got both positive numbers this time, so we have to think a little bit. Which one is greater? So the 4 is greater than the 3, so 4 is going to go on the right, 3 is going to go on the left. We don't have an equal to, we just have greater than and less than, so we're going to have open circles. And for the 4, it says x is greater than 4, so that's shading to the right. And for the 3, it's x is less than 3, so we're shading to the left. Okay. So I put these 3 on the front page for a reason. All 3 of them are greater thans. One of them was a greater than or equal to, but all 3 of them are greater thans. And they all shaded in similar ways. They shaded away from their numbers, outside of their numbers. So what happens when we have less thans? And that's the next page. So for the next one, I'm going to set it up exactly the same way. X plus 2 less than 6, and negative parenthesis x plus 2 less than 6. I'm going to subtract 2 from the inequality on the left and get x is less than 4. For the inequality on the right, I'm going to distribute that negative and get negative x minus 2 less than 6. And I'm going to add the 2 and get negative x less than 8. Divide by a negative 1, remembering to flip my inequality, so now x is greater than negative 8. And I'm going to put my numbers on the number line. Negative 8 goes on the left because it's less than 4. This inequality doesn't have an or equal to, so we're going to do open circles. And then I'm going to check my inequality. It says x is less than 4. So let me do a highlighter real quick. If I shade less than 4, I'm going to start at that open circle and shade to the left. And that hits the negative 8. Well, what happens with the other inequality? It says x is greater than negative 8. So I'm going to start at negative 8 and I'm going to shade to the right. The solution is where they overlap. And so they overlap in between the two values. Okay. Let's try the next one. So next one, similar story. We're going to say 2x plus 1 less than or equal to 9, and negative 2x plus 1 less than or equal to 9. For the left inequality, I'm going to subtract 1 and get 2x less than or equal to 8. Divide by 2 and get x less than or equal to 4. For the one on the right, I'm going to go ahead and distribute and get negative 2x minus 1 less than or equal to 9. Add 1 to both sides and get negative 2x less than or equal to 10. Divide by negative 2 and get x, and we divided by a negative, so we've got to remember to flip. X is greater than or equal to negative 5. So I'm going to put negative 5 on the left because it's less than 4. We've got or equal to's this time, so we're going to do solid circles. And then we're going to look at our inequalities. So the first one says x is less than or equal to 4. So less than or equal to 4 shades to the left. Greater than or equal to negative 5 shades to the right of negative 5. We've got an overlap, and that overlap is going to be our solution. Let's try one more. So this one, we're going to set up our two inequalities. So 7 minus x less than or equal to 4, and negative 7 minus x less than or equal to 4. For the inequality on the right, I know that the negative x is second, and usually we move the second thing, but I want that x by itself. So I'm going to move the 7 instead. So I'm going to say minus 7 and get negative x less than or equal to negative 3. Divide by a negative. Be careful with this one because usually it's been the second inequality where we've divided by a negative. This time it's the first. So that means I'm going to have x is greater than or equal to positive 3. Inequality on the right, I'm going to distribute. So I'm going to have negative 7 plus x less than or equal to 4. I'm going to add the 7 and get x less than or equal to, let's see, 11. No negative on that one. So I'm going to put the 3 on the left and the 11 on the right because 3 is less than 11. Solid circles because we've got or equal to's this time. And then when we shade, I know I'm going to shade in between because we've got a less than to start off, right? We started off with this less than or equal to. But just to double check, let's go ahead and say for the 3, x is greater than 3. So I'll shade to the right. For the 11, x is less than 11. So I'll shade to the left. And I've got some overlap in between, just as we suspected. Okay. For all of these, let Desmos be a good tool for you. So if I'm not sure about one of these, let's look at what one of these looks like in Desmos. So I'm going to do 7 minus x less than or equal to 4. So let me set up 7 minus x less than or equal, which is down here in this little tab. Let me get that 13 out of there. Less than or equal to 4. So sure enough, if I scroll over here a little bit, I see 3 and 11, which is what we got when we did this problem, 3 and 11. Solid lines because we had nor equal to, and the shading was in between.